In our ecosystem, scalability is achieved through clustering. This architecture allows multiple physical nodes to operate as a single logical service. By configuring a cluster, you ensure that traffic processing is shared across nodes, preventing any single node from becoming a bottleneck. It is important to note that a cluster is not always distributed. For instance, local mode keeps all data on a single machine. This architecture ensures that our solutions are reliable through redundancy and easily scalable as traffic demands grow. To transform a standalone instance into a high-availability cluster, you must configure the following parameters. The cache type determines the logic behind your environment. Depending on the type you select, the interface will dynamically display different configuration fields that must be specified. Local, used for standalone instances only. It provides no clustering and features the most minimal set of fields. InfiniSpan, an open-source in-memory data grid, IMDG, that is built directly into the Java memory. Unlike other providers, it typically uses UDP multicast communication by default to discover nodes in the cluster. When selecting InfiniSpan, additional fields appear to manage data distribution. Replicated determines the data distribution strategy. If set to replicated, all cached nodes maintain a full copy of all data. If set to distributed, the data is spread across the cluster nodes. Copies sets the number of data copies for the distributed mode. For instance, if you have 3 cached nodes and set copies to 2, each node will hold 66% of the data. This proportion adjusts based on the number of nodes and copies to optimize memory usage while ensuring redundancy. Hazelcast and Apache Ignite. These are powerful computing platforms that run on separate, dedicated servers rather than being embedded in the Java application memory. Choosing these requires configuring host and port fields to establish a connection to the remote instances. In the host field, you can provide a list of hosts, boot nodes, from which the solution can discover and learn about all other nodes in the server's cluster. Like InfiniSpan, Hazelcast allows you to combine the RAM of several servers into a single virtual space. It features a built-in engine for stream processing, allowing for real-time data handling without database delays. Apache Ignite is the most robust option, offering native persistence to store data on disk as well as in RAM. This allows for handling datasets larger than available memory and provides full-scale SQL support, ANSI 99, for complex queries and joins. Serialization type. This defines how data is packaged for transmission between nodes. The choice of serialization affects communication speed and resource overhead. Native uses the default serialization method of the specific cluster solution you have selected for optimal compatibility. Creo, a high-speed third-party framework recommended for heavy production traffic due to its small data footprint. Java serialization and JBoss marshalling, standard and optimized alternatives available for specific compatibility needs, though they may produce larger data packets compared to Creo. Cluster name, a unique identifier like USSDGW, which allows the application to search for other nodes and rebalance data within the cluster. Acquire timeout, the maximum time, in milliseconds, a node will wait to gain access to shared data. Termination timeout, the grace period for tasks to complete when a node is shutting down. Command timeout, the time limit for administrative commands to execute across the cluster. Clustering is the engine that makes our system reliable and scalable. Whether you utilize the embedded efficiency of InfiniSpan or the dedicated power of Hazelcast and Ignite, selecting the right combination of cache and serialization ensures your gateway is hardened for high-stakes operations.